Welcome to the demo of automation of HVAC simulation process. Before going into the details, let's first discuss the challenges faced by automotive suppliers due to the short product development cycle time. Nowadays, customer wants product performance already at time of proposal. This leads to increasing number of simulations, but not enough analysts are available, and it is impossible to do the simulations in time with existing traditional approach. There is no in-house resources nor know how to create a robust automated simulation process due to complex geometries and simulation physics. Suppliers needs to ensure that the simulation results are always comparable independent of who, when and where they are done. Also, they want an ability to preserve simulation know-how when analyst leaves. So, Novus Nexus have solution for the above challenges through our unique product called CA Nexus. We present the automated simulation process for product development engineers. With this process, no analyst needed to run simulation and 24 by 7 operation possible. As it is a end-to-end process, designer will get the report for each design variation they submit, and the automation is done through low-code tools like CA Nexus and ESA. This largely avoids scripting and programming. CA Nexus handles geometries with highest complexity. The simulation physics configured in reusable abstract models. The abstract models preserve simulation technical knowledge or know-how in an easily understandable fashion. This is the overview of automated simulation process. The main automation tasks are preparation of simulation ready CAD model, preparation of abstract model, then application specific GUI preparation, and fourth one is workflow manager and GUI configurator. In brief, designer will prepare the simulation ready CAD model and upload it on ESA. The already set up abstract model file will be used for this automation. Next, in CA Nexus, CAD to solver automation takes place, and in this it will automatically export the job and it will run the simulation, and using CA report it will post process the simulation results and prepare the simulation report and email it to the designer. The functions inside this box are configured, no need for scripts or programming. Also, the functions controlled by this workflow manager implemented through scripts and macros. So data transfer, parameter transfer, start of application, submit job, error handling, all these tasks are done by this workflow manager. Now we will see the details of main automation tasks. This is a simulation geometry for HVAC prepared by designer. This is inlet, this is scroll, the green one is MRF fluid, this is diffuser, this one is evaporator, the red one is heater, this is casing with different outlet ducts like defrost outlet, panel outlets, and floor outlet. The yellow ones are door, and by changing the door angles, designer is achieving the different operating modes. Designer have specified the parameters for these door angles, and by changing the value of these parameters, the designer will achieve the different operating modes. All the fluid parts are extracted by the design. The purpose of this simulation is to get the mass flux distribution at different outlets, also to get the pressure drop across different components, and the temperature distribution at different outlets for different operating modes. Designer has given some parameters. Here you can see one parameter as SCOM. We call it as simulation component, and some parameters like S classes, we call it as simulation classes. SCOM represents component name, and S class are strings that represents physics in simulation. Like air is used for defining cell zone condition, fluid class is used for defining boundary conditions, and size C is used to define mesh sizing. These parameters are recognized by CA indexes. SCOM names are unique, but S-class names are not unique. You can use same name between different parts as per your physics requirement. So this is the simulation geometry prepared by designer. This is CA Nexus abstract model window. On left side, there are different classes are defined, and here the relation between different classes are created. There are 4 tabs. In meshing tab, we specify the meshing attributes, like on size A class, we have defined the mesh size. In solution strategy tab, we specify the solver settings, like we have defined the turbulence model. And this is problem definition tab. Here we specify the boundary conditions, cell zone attributes, and some attributes that will use for report generation. And output tab has post-processing attributes. There are 3 main advantages of using abstract model. First one, this file serves as knowledge template because all the attributes and its values are stored in this abstract model file. Second, this is geometry independent file, as all the attributes are specified on classes and their relations, not on any geometry. Third one, all the knowledge of analyst or know-how of simulation is captured in very compact way and could be reused in different simulations. Let me explain how this cell zone attribute on air class will be transferred to respective volumes. So when we combine the abstract model with the simulation geometry that created by the designer, then it doesn't matter whether air is present as class on 10 volumes of that geometry or 100 volumes of that geometry. So this air, so this cell zone attribute will be transferred to all the volumes containing air class. So here we can see on air class the cell zone attribute is defined. Next, in model tab, we can see that the attribute is splitted as per the number of volumes present in the geometry. So with this one attribute in a real simulation, the cell zone will go on multiple volumes. This is the compact way to capture the knowledge. We can use this file with different geometry which has this air class. Hence, the knowledge could be reused. This is why all the classes represents the names which is physics in that simulation. This is the role of analyst. He or she will create this abstract model file and this can be reused for different simulations. This is simple web application created for this demo in ESA. Here, designer will choose the CAD modeler and its version. Then designer will upload the simulation geometry on computational server. So I am choosing the geometry and uploading it. So here we can see that the geometry is uploaded. Here designer will select HVAC operating mode and the door angle parameters are automatically get updated in UI. So currently default mode is panel mode. So if we select the defrost mode, the door angles get changed. Next is floor mode. The defrost door gets closed, panel door gets closed, and it will open only floor door. Next two modes are mixed modes, the floor panel and floor defrost mode. Also, we have given option to select the checkbox and manually set the door angles. Here, designer will specify the temperature value and fan speed. Next, he will select the evaporator and heater model. If everything is done, then designer will click the submit button and it shows that application is successfully submitted to the computational server. So nothing is running on my local machine. All the processes like geometry preparation, pre-processing, exporting the job to the solver, running the solver, post-processing, then creating report is carried out on computational server. This is my result dashboard. Here we can check the status of the simulation we are just started. We can see that the status of previous simulations too. Currently, it is showing geometry preparation as we are changing the door angles using parameters. The status keep updating till completion of report generation. These are the files. Those are all running on computational server if someone wants to check them. This is the simple way to submit and run simulations. This is the demo application we have created for HVAC. We can customize and create new application as per the customer requirements. As solver takes time to run the simulation will not complete during webinar. So we will directly see the previously generated report. This is the email I got after completion of simulation. Let me download this report and show it to you. This is the simulation report. This is the contents page. One by one, we will see the details of the report. The first page is simulation input page where we have defined all the inputs. Next, air flow and temperature distribution. Next slide is the pressure distribution. Next is the pressure drop across different components. Next, computational domain. This is my geometry. This is a sample mesh and this is the total mesh count. Then these are the contours, the temperature contour, pressure contour, velocity contour, velocity contour at blower center, velocity vector at blower center, and velocity vector through HVAC. And at last, we have the simulation statistics. The report is generated based on abstract model settings. This is simplified generic report for demo purposes. Actual customer reports could be more comprehensive. AMF based report creation is still under development, so not all features are available. Now we will quickly see workflow manager and GUI configurator, which is ESA application. There are two main tabs, one for defining user interface and second one is used for process definition. In user interface tab, we define the parameters which will be shown in the web application GUI. Like here, we have defined the operating mode choice list. So designer will select the operating mode. Next, these are the different door angle defined. And here in input tab, we have given option to define the temperature. And here we have given the option to define the fan speed. In process tab, all the processes are defined and sequentially they are executed. So we can briefly see that in Creo parameter change process, the geometry will get updated as per the door angles defined in the GUI. The CAD model will get updated and it will pass on to the run prep process where the export of the job takes place, that is CAD to solver automation takes place. Next, in run solver process, the simulation will start and it will write the simulation data after completing the specified number of iterations. Next, in run report process, it will start post processing as per the abstract model settings. After completion of solve process, it will start post processing of simulation and extract the required solver data. Next, it will club all the information in predefined format and create the report and email it to the designer.